So in this video, we will be talking about how to solve quadratic equations and every possible way to solve them, ranging from solving them algebraically to geometrically. And here we're going to be solving quadratics of the form ax squared plus bx plus c is equal to 0. And how do we find x, you're wondering? Well, there is a process to get a formula, and the process is first divide by a, but also subtract c from both sides to get this. X squared plus b over a x is equal to c over a. Now I want to go ahead and divide by 2. So we have x squared plus b over a x plus b over 2a all squared is equal to negative c over a plus b over 2a squared, which basically makes the left-hand side a perfect square of x plus b over 2a squared is equal to negative c over a plus b squared over 4a squared. And simplifying the right side, we have x plus b over 2a squared is equal to negative 4ac over 4a squared plus b squared over 4a squared, where we could group the like terms since they have the common denominator at the bottom, and take the square root. We have x plus b over 2a is equal to the square root of minus 4ac plus b squared over 4a squared, which basically simplifies down to x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac over 2a, where we can go ahead and group this again, giving us our quadratic formula. And with this, we're able to solve any quadratic we want. It doesn't matter whether a is negative or a is a fraction, we will always get the answer using the quadratic formula. So that is how to solve any general quadratic simply. And our answer will be written up here. So we have our formula at the left-hand side or the top left corner. And we are going to see a few examples and use the quadratic formula. So we're just going to go ahead and use an example where we have x squared plus 6x plus 9 is equal to 0. So we're going to plug in a, b, and c. Since a is 1, b is 6, and c is 9, we're going to get x is equal to negative 6 plus or minus the square root of 36 minus 4 times 1 times 9. That is positive 36 or negative 36 because minus 4ac. We have negative 36 and all over 2 times 1. Since a is 1, we don't need to write 1 down. So we just have this, giving us x is equal to negative 6 over 2 is equal to negative 3. Since the inside of the square root cancels out, because it is 36 minus 36, giving us the square root of 0. So we have negative 6 over 2, which is negative 3. And this is telling us that our answer is going to repeat itself twice. So we have x is equal to -3, comma -3. So that is what it tells us and how many solutions we get. But something important that you need to take note of is the discriminant, which is usually written as delta, but we're going to use d as the discriminant, which is equal to b squared minus 4ac. And what's inside the discriminant is basically going to tell us how many solutions we have. So we're going to write the discriminant as b squared minus 4ac, and we're going to look at all of the cases. So we have when discriminant is equal to 0, we get one solution. And when delta is greater than 0, we get two distinct roots. And when delta is less than 0, we get two complex conjugates. So that is a quick rundown on what the discriminant is going to tell us. So we're going to go see how we can apply the discriminant and use it to determine how many solutions we have. And we're going to use a quadratic, which is going to have two complex solutions, and we'll see how or what our discriminant tells us, and we're going to solve for those two solutions. So you have x squared plus, or actually minus 2x is equal to, or plus 2 is equal to 0. And we want to go ahead and look at our discriminant, which is going to tell us what our solutions are. And we're going to detonate it by using delta is equal to b squared, where b is -2 and c is +2 and a is +1. So we have -2 squared minus 4 times 2, because we don't need to write down 1 since it's just going to be doing nothing. This gives us +4 minus 8, which is equal to -4. So that means what is inside the square root is going to be -4. And we're going to go ahead and use this and write it down into our solution, where we get x is equal to +2 plus or minus the square root of -4 over 2. Since 2 times 1 is just 2, we're just going to leave the bottom as 2. And we have 2 plus or minus 2i, because the square root of -1 is equal to I. And it's all divided by 2. So we basically get that x is equal to 1 plus or minus I. So now we're going to go ahead and look at a different example. And this time we will have two solutions, but they're all going to be different. So let's go ahead and look at a quadratic where we're going to have x squared plus 3x minus 9 is equal to 0. So we're going to go ahead and use a quadratic formula, giving us x is equal to -3 plus or minus the square root of 9 plus 36 over 2. And this is going to tell us, or basically give us, -3 plus or minus the square root of 45 divided by 2. And now we can't simplify our expression anymore since we basically are going to just be left with this, where we could also try to basically simplify what's inside of the square root, but we're going to leave it like that since that is going to be the expression we're going to have. So we basically get x is equal to -3 plus or minus root 45 all over 2. So we're going to go ahead and look at the next method, which is called completing the square. And just like we did with getting the formula for the quadratic, that's exactly the same process we're going to go ahead and follow. So let's just start off with x squared plus, or 2x squared plus 4x minus 2 is equal to 0. Or actually, yeah, just this quadratic, and we're going to go ahead and have to divide by 2. So we have x squared plus 2x minus 1 is equal to 0. So now what we want to go ahead and do is move -1 to the right side. So we have x squared plus 2x is equal to 1. We're going to go ahead and divide 2x by 2. So we get plus 2x is equal to, or no, plus, since we're basically adding it as well, 1 squared is equal to 1 plus 1 squared. And this is going to give us x plus 1 squared is equal to 2. And we're going to get x is equal to -1 plus or minus root 2, which is going to be our solution to this quadratic since we're completing the square. And if you are curious on why it's called completing the square, well, I will go ahead and show you an example, and I'll show you geometrically how we complete the square. So we have x squared plus, let's see, 4x is equal to 12. We're going to go ahead and look at x squared as a square with sides x by x and with an area of x squared, but we'll leave it like that for now. And we have a rectangle of 4x, but it's going to have side lengths of 4 by x. And we want it to be equal to a square with an area, well, not a square yet, since we're going to have a shape like this. All of this is going to have an area of 12. So area is equal to 12. And here we want to basically go ahead and find a way to make this into a whole square so that we complete the square on the right side as well. And to do so, we're going to go ahead and look at our rectangle and divide it in half exactly so that we get x by x and a rectangle now with, or two different rectangles, so we get 2x and 2x. And we could rearrange this as shown, and we're going to get almost a square. And here are the lengths. And what we want to do now is multiply 2 by 2 because we have 2 on the long sides of the rectangles, which is basically going to give us a new square since we're multiplying 2 times 2 is going to give us a new square with the volume, or not volume, an area of 4. And with this, we also have to add this exact square to the next square that we were looking at earlier. And it is going to give us a square on both sides. And we have the new square, which is also going to have an area of 16. And going ahead to complete the square, we're basically going to take the square root of the new square that we have. So here we have area is equal to 12, or not 12 anymore, 16. And we want to take the square root of the new area of our square, so we get 16, or the square root of 16 is equal to 4. So that means that the square root of the square on the right is 4, meaning that we have x plus 2 is equal to 4. And we're going to subtract 2, and we get x is equal to 2, because 2 minus, or 4 minus 2 is 2. And if we go ahead and plug in 2 into x, we basically get that our square has a volume of 4, not volume, an area of 4. So does our rectangle. So we have 4, 4, 4. And if we add all of this, we're basically going to get a square with volume, why do I keep saying volume? Area of 16. So with that, this is how we basically solve quadratics by completing a square geometrically. And that is how we basically get one of the solutions, because when we're dealing with a square or any shape, we're only going to look for the positive solution because we can't have area or negative area, since it would basically not make sense. But since we have x plus 2 is equal to 4, since we took the square root of 16, is going to be plus or minus 4, where x is equal to 2 and negative 6. So those are our two solutions for the quadratic that we were looking at. And we're going to go ahead and look at how to complete a few more examples by completing the square, but not visually geometrically. So we're going to look at a different one that has b as an odd number, and we're going to have plus 8 is equal to 0. So we're going to go ahead and subtract negative 8, or actually we're going to also have 8 equal 3. So this is a difficult example we're going to look at. So we're going to go ahead and divide by 3. So we have x squared plus 7 over 3x plus, or is equal to negative 8 over 3. And we're going to go ahead and divide the 7 over 3 by 2, giving us x squared plus 7 over 3x plus 7 over 6 squared is equal to negative 8 over 3 plus 7 over 6 squared, so that we get x plus 7 over 6 squared is equal to negative 8 over 3 plus 49 over 36. And we're going to go ahead and multiply negative 8 over 3 so that we get a common denominator of 36, and by multiplying by 12, we basically see that we get 12 times 3 is basically 36, and 8 times 12 is negative 96 plus 49 over 36. We're going to get x is equal to negative 7 over 6. Well, I skipped a bunch of steps there, but since we're taking the square root and subtracting negative 7 over 6, we could do it all at once. So plus or minus 6, and 49 minus 96, or yeah, 49 minus 96 is going to give us negative 47. So we're going to have the square root of negative 47, or 47 times I. And that is going to be our solution. Let's go ahead and group it. So we have negative 7 plus or minus I root 47 all over 6. So that is our solution to our quadratic by completing the square. It's quite a time-taking process if you were to have numbers that can't easily be divided and you're dealing with fractions. And this completing the square is pretty useful to know, since we could also use a quadratic formula, but completing the square is more beneficial when you could do it fast. So we're going to go ahead and look at a different example, which is kind of more interesting, since we're going to be depressing the quadratic, since we're going to set x is equal to y minus b over 2a. And we're going to go ahead and look at an example so that we can go ahead and depress it. So we're going to start off with x squared minus 4x plus 5. And we're going to go ahead and set x is equal to y minus b over 2a. So we have x is equal to y plus 2, because negative and negative make a positive. So we have 4 over 2, which is positive 2. And now we're going to have y plus 2 squared is equal to y squared plus 4y plus 4. And negative 4 times y plus 2 is going to give us negative 4y minus 8 plus 5. And here we're going to have y squared, since the 4y's are going to cancel out. And we have 9 minus 8, which is positive 1. So if we go ahead and look for y, we're going to get that y is equal to plus or minus the square root of negative 1, which we can write as I as the imaginary number. And we can go ahead and plug y in for y and x equals y plus 2. So our solution to our quadratic is going to be x is equal to 2 plus or minus I. And that is going to be our solution for our quadratic, since we simply depressed it. And that is also one other way to derive the quadratic formula, but it is less known since it is not mostly taught. But we're going to look at one more example, but that involves fractions. So we're going to go and look at x squared plus x plus 1 is equal to 0. And we're going to set x is equal to y minus 1 over 2. And we get to plug in y minus 1/2 into x, giving us y minus 1/2 squared is equal to y squared minus 1y. plus 1 over 4. And we're just going to have y minus 1 half plus 1. So now we're going to go ahead and find our solution. So we have y squared minus y plus 1/4 minus 1 half plus 1. So the y is going to cancel out, where we are left with y squared plus 5 over 4 minus 1 half, which is the same thing as y squared plus 3 over 4 is equal to 0. And we're going to get y is equal to plus or minus 3 or root 3 over 2i, where we can replace y and it will give us x is equal to -1 plus or minus I root 3 over 2. And it takes some time to work around fractions, but if you understand how to convert fractions into numbers and numbers into fractions, then this method could be quite easy. But we're also going to go ahead and talk about a different quadratic formula, which is known as Mueller's method, where we have x is equal to 2c over the square root of b squared minus 4ac, and minus b plus or minus square root b squared minus 4ac, which is a less common quadratic formula, but it is mainly used in Python and coding. So let's go ahead and write that down on the top right. So we have x is equal to 2c divided by minus b plus or minus the square root of b squared minus 4ac. So we're going to solve a few examples using Mueller's formula, and we are going to have to look at the example x squared minus 3x plus 2 is equal to 0. So we're going to get x is equal to 2 times c, which is 2 times 2, which is 4. And b is -3, so we're going to get +3 plus or minus the square root of 9 minus 8, giving us plus or minus 1. And we get 4 divided by 4 because we're doing 3 plus 1. And we also get 4 divided by 2, where we get x is equal to 1 comma 2. And let's go ahead and verify our solutions into our quadratics. So we have 4 minus 6 plus 2, which is when x is equal to 2. And for x is equal to 1, it is going to be 1 minus 3 plus 2. So that is a quick little interesting formula for people who want to use it. And we are also going to go ahead and discuss how to solve them, or quadratics, geometrically by considering some shapes like hyperbolas and straight lines. So we're going to go ahead and look at a quadratic like x squared plus or minus 2x is equal to 3. So we're going to move 2x to the right hand side, so we get x squared is equal to 2x plus 3. And we're basically just going to divide by x, so we get x is equal to 2x plus 3 divided by x. And we can go ahead and just plot the separate equations on a graph. So we're just going to quickly do this as an example, since it is not very much a reliable way, but we're just going to have a x, which is going to cross from 0 to infinity. And we also have a rational function or a hyperbola, as is that is the shape of it. And we're going to have to plot a few points before 1. We see that it's going to be at 5. Well, actually, I'll mark it in yellow. It crosses at 5 when x is equal to 1. And when x is equal to 2, it is 7 over 2, which is around here. And when x is equal to 3, it is equal to 3. And that tells us that it's going to look something like this, which is not really drawn to scale. And then we'll just continue going downwards slowly. But since it has a horizontal asymptote at y is equal to 2, that means that it's never going to go under its horizontal asymptote. Though it may cross it, but in this case, it is not going to go below its horizontal asymptote. And for our second one, we are also going to go and see what is -1, which is -1, which is going to also intersect with the linear function, and it's going to just approach from the bottom, cross 1, and then have a shape like that. And that is just how to solve them visually or get an idea of where the roots are. But this method is not really useful. But since it's kind of cool to know, then I decided to list it here. But that's pretty much it when it comes to solving quadratics with two different equations. So now we're going to talk about how to factor quadratics. So we're going to have an example like x squared plus 4x plus 3 is equal to 0. We want to see two numbers that multiply to 3 and that add up to 4. And here we have that those two numbers are u is being 1 and v being 3, because 1 times 3 is 3 and 1 plus 3 is 4. So once we have those, we basically write it out as x plus 1 times x plus 3. Since if we go ahead and factor or distribute this, we're going to get x squared plus 3x. And if we go ahead and distribute the 1, we're going to get plus x plus 3, which gives us x squared plus 4x plus 3. And what happens if we have a quadratic with a number in the front? So we're going to look at 2x squared minus x minus 1 is equal to 0. And we want to go ahead and factor this expression so that we can get the solutions. But here we have what a is greater than 1. So what we can do is go ahead and multiply a and c, which is 2 times -1, which is going to give us -2. And now we basically just want to find those two numbers that basically add up to -x. So the new quadratic we're going to look at is minus x minus 2 is equal to 0. But the solutions for this are not the same solutions for the quadratic we're looking at. So we want to go ahead and find two numbers that multiply to -2 but add to -1. And those solutions, or those two numbers, are u is equal to -2 and v is equal to 1, because -2 times 1 is -2 and -2 plus 1 is -1. So we write our answer, or our factored form, as 2x squared plus x minus 2x minus 1. And we can group like terms and factor out some common factor. But let's go ahead and group 2 and 2 so that we get 2x squared minus 2x. I'm going to put parentheses around them so we know that we're grouping them, plus x minus 1. And we see that we could get an x minus 1 from here, where we will go ahead and factor out 2x. We have 2x times x minus 1 plus 1 times x minus 1, giving us that our factored form is going to be x minus 1 times 2x plus 1. And if we were to go ahead and multiply everything inside the parentheses, we're going to get 2x squared minus 2x plus 1 minus x and minus 1. So that is basically going to give our solutions, and we just have to set every factor equal to 0. So we have x is equal to 1 and x is equal to -1/2. So that's going to be it for this video, and thank you for watching, and I hope you found some of these methods to solve quadratics interesting. And yeah, I hope you have a great rest of your day. Thanks for watching.